Okay, good afternoon everybody. My name's David Eagle from One Spatial. Welcome to this one of our FME training sessions that we've been doing for the last few months. This is an online session. It's free to attend, and we're going to go and look at FME for AutoCAD users in particular today. We'll take a look at a number of capabilities that FME has when you're working with Autodesk products, and how you can work with AutoCAD drawing files and the likes of DWGs and DXF files using the FME Desktop product. There's a number of things that we're going to take a look at. We'll have a brief review of One Spatial and Safe Software and our relationship. We're also going to take a look at how you can view your data and what format support there is in the FME product for AutoCAD. I'll show you how you can translate your data, style your data, and also work with AutoCAD Standards, which is an important topic that a number of people have asked me about in recent years. We'll also be looking at how you can tile and file your data for use in CAD when you're taking data and migrating it between GIS systems and AutoCAD systems and vice versa. I'll also show you how you can auto extend your AutoCAD Map 3D product with your FME license. So very briefly, a quick overview of One Spatial. We've been around now for a number of years, since 1969, and really our focus is on data quality. And we've worked with quite a few organisations from national mapping agencies through to local authorities, providing services to assist those customers with their asset data, managing, improving and reviewing the capability. We use our own products for that kind of capability. We also use third-party tools just like FME. So what we're going to do is also take a look at the capability that FME has. Safe Software are the vendors of the product FME. They've been around since 1993, and some of you will already be aware that they're based over in Vancouver. So we act as a reseller for Safe Software in the UK. FME is used by thousands of professionals around the world who want to work with data processing, data translation, and the reason that FME has carved such a niche and has become a standard de facto tool for working with your spatial and non-spatial data is because of the unrivaled data connection capability. FME will work with all of the vendors that you can see logos for in front of you, as well as many more, and obviously the focus of our attention today is going to be around the Autodesk connection. We've got a capability in FME that covers both FME Desktop and FME Server. We have one of the largest numbers of certified FME professionals and certified trainers globally, and we also provide a number of FME services. I'll go into that in a little bit of detail at the end, but really what I want you to take away from this session is that we will help you evaluate FME if you're a brand new user of the product, so that you can work out whether it will do for you exactly what you need. We can provide consultancy, training and also technical support services in use of the two core products. The focus really is going to be on FME Desktop though for this session, and often brand new users are not quite sure what the product does, although it's very immediately obvious from some of the marketing that surrounds the product that highlights that it is a data translation tool. But really the power that lies in FME is with the engine. So FME can process data from a MapInfo tab format and write it to an AutoCAD DWG, but FME also knows that DWG can write data out to GML, but GML cannot write to NTF. So there's a large support for formats in FME, certainly since FME 2012 was released earlier this year, the format support in the product now is over 270 formats. So an unrivaled data support. When you install FME as a product, you get a number of components with that installation. We'll focus really on these two products on the right hand side, the FME Universal Viewer and the new Data Inspector, which allows you to work with 3D data. Also the Workbench tool for writing your FME scripts. You also, however, get a universal translator to quickly translate data from one format to another. You can operate FME on the command line, and there's also an application extension capability, and certainly within this topic that we're looking at today, you can extend your FME license into the AutoCAD product as well. For those of you who have been using Autodesk for a little while, you probably don't need any introduction to the product. But one thing to note is that those of you out there using AutoCAD are perhaps using one of two main tools, AutoCAD LT or AutoCAD Lite, as it used to be known, and also AutoCAD Map 3D. The main difference between the two products is that Map 3D is really the tool that has the GIS-like capabilities. So you have the ability to work with attribution, map projections, and really coordinate space within the Map 3D tool. And obviously the name indicates that you can work with the third dimension. So FME has support for working with data that typically you would use in either of those two tools, as well as civil design and some of the other AutoCAD products, which we'll see some details of in a little while. But really AutoCAD is a highly functional drawing package that is used by a lot of different industry professionals for drafting and creating detailed drawings. Now throughout this training session there will be these blue slides that pop up every now and again. I'm more than happy for people to put messages into the chat window if you have any questions throughout the session, and you're also welcome to speak to us directly if you want to open up your microphone to have a chat at the end of the session. But the blue slides will indicate the movement between one topic and another, and within this hour's session we'll try and squeeze in as many topics to allow you to see some of the capability that FME has around the Autodesk toolset. So we'll start off looking at visualization of your data and how you can do that with FME. Now, if you've used FME for a little while, or you're brand new to FME, you'll maybe be aware through a little bit of a review of the tool that there is something called a universal viewer available to you. That allows you to inspect your data, the complete geometry, all of the attributes, and you can literally do a file and open up a tab file, a shape file, a connection to an Oracle spatial database. You could connect to a table in MySQL or SQL Server, and you could open up a DGN and a DWG and open all those formats in the same window at the same time and inspect the data. The only stipulation is that the data has to be in the same coordinate space, but that's typical of many applications. But no translation is required to be able to view that data all in one environment. For a couple of years now there's also been another tool available. It's called the Data Inspector. This ultimately will replace the Universal Viewer, and the Data Inspector allows you to inspect 3D data. So if you want to work with data in the third dimension and view it, then you can use the Data Inspector, and I'll show you how those tools both work now. So let's go and have a look at the Universal Viewer and the Data Inspector. So if we fire up the Universal Viewer to begin with, we'll just go and open up some simple data. So let me just grab this path, and to begin with we're just going to open up a Mr. Sid set of aerial imagery, and we've got a number of Mr. Sid files sitting on this path here, which we're going to read in, and it's a set of tiles which gives us a backdrop. So if we just zoom extents, you can see a little bit of aerial imagery, some air photos. So Mr. Sid is a highly compressed image format. from Lizard Tech, and we're going to add into this window some more data, and we have, I believe, some FME data. So we have some land parcels for this area as well, and we can see if we zoom extents, we've got some building boundaries included in here. Okay, so I'll just toggle off the Mr. SID data for a moment. You can see the boundaries. And lastly, we're going to add in some AutoCAD data. So let's go and open up a DWG. So the drawing file here, and you can see how easy this is to open up different data formats all into the same window. And you can see in the navigator view here we have a connection to the Mr. SID tiles, which I can turn on to see the raster imagery, the FME data and the AutoCAD data. And the difference with the AutoCAD data is that I opened one file, but inside it there are 3 layers. So if I turn off the Mr. SID data for a moment, and you can see that we have, if we zoom in a little, some water meters, some distribution nodes, and also some pipelines as well. So let's look at those independently. Each of these have a number of features. We have some attribution. You can see that, for example, there are some, if I just navigate my way down a little bit, there's some extended entity data. With FME you can get the extended entity data exposed by simply clicking a button when you open the data, and you can see here that we have the attributes stored just as normal attributes. FME treats them as normal attributes. Extended entity data is information that you can tag onto your drawings, often using third-party AutoCAD tools. So we've got access to that information. This drawing file also has a coordinate system associated with it, so we're in a Texan coordinate system using this sample data. And what you'll also see is that there are a number of attributes that are prefixed with the word AutoCAD, which indicates that this is information that the drawing file contains to influence the way that AutoCAD works. So you can see here that the AutoCAD layer is called water distribution lines, and it's not frozen within the drawing file, and the line type has been set by layer. So a lot of information that AutoCAD needs that normally you'd have to expose in AutoCAD, FME can also access as well. So visualizing your data using the universal viewer is very quick and simple. So if we just minimize that for a moment, and what we're going to do is just navigate our way to an alternate tool. If we go to Start All Programs and move to the FME Desktop location, you can see that there's something here called the Data Inspector. As I say, the Data Inspector is relatively new. It's what's classed as a technology preview, which means that it's not officially a tool that, say for, it's been shipped with the installer, but it's not the main visualization application just yet. We're hoping that will switch over next year. We can drag and drop our files very simply. This is a DXF this time. You'll see that FME automatically recognizes that it's a DXF file, and we've got some parameters to choose in the way that we want to read our content. Specifically, we want to expose the Z value in this data because I mentioned that this is a 3D viewer. This will read the DXF file and connect to all the features and bring in the data. And this is Ordnance Survey Landform Panorama. This is open data that you can go and download yourself. You can see in here there's a number of G prefix layers, and if I turn them all off, the one that I'm interested in is 200 and layer 201. We can turn this data into 3D and go to Rotate and navigate our way into the map in a bit more detail, and now we can see that the third dimension has been exposed and the Z value has been extruded so that we can see the topography of this particular area. If I use the information tool and go and select a feature, we can see very quickly that we've managed to select one single contour line, and if we scroll down a little bit you can see that that's a 500 meter contour that we have selected there. The units of measure in FME are typically dictated by the coordinate system that you're working with. This data happens to be in British National Grid, which means the unit of measure that we're looking at is going to be defined as meters. So if we close down this data inspector, we're going to make our way through the rest of the presentation. But hopefully that gives you a nice overview of how you can work with viewing your data quickly with the Data Inspector and the Universal Viewer. We'll take a look now at format support. Format support in FME for AutoCAD's formats includes the standard DWG and DXF reader and writer. So this is the reader gallery, so you can see that FME can read DWG and DXF. It can also write those formats. You'll also see that AutoCAD supports something called real DWG. Now this might not be immediately obvious what this is to some of you if you've used FME for a little while. I'll go into the details of that in a moment. There is also, however, support for Map 3D's object data. So if you work with object data in AutoCAD Map, object data is a little like traditional attributes that you would see in a GIS tool. And AutoCAD supports those within the Map 3D product, but you need to use a separate reader and writer to work with object data. There's also support for Civil 3D, and I'll go into a little bit more detail in a short while. When you're working with FME though, the reader and writer gallery, there will be some formats that are greyed out. They are greyed out for one of two reasons. Either your FME version, your FME edition, is not appropriate for working with that format, or you need a third-party bit of software installed on your machine. In the case, for example, of Oracle, if you don't have the Oracle client installed on your machine, FME has no way of connecting through to your Oracle database. So in that case, the Oracle reader would be set and greyed out. There is also an FME Oracle edition, so you need to satisfy those two prerequisites to be able to work with an Oracle database. So when it comes to the first reader that we just highlighted there, the first reader and writer, this is the AutoCAD reader, and it's actually an open source set of libraries that comes from the Open Design Alliance. It's supported on both 32-bit and 64-bit operating systems in the Windows environment, and also is supported on Linux and Solaris. So that's a very useful capability. There is, however, also a real DWG reader and writer, and I would encourage people to consider using this. The prefix is just real, so just search for DWG and you'll see it listed there as a real reader. The only reason I'm highlighting this is because this is the one that isn't necessarily the default when you do your search, but actually it's the one that uses the official Autodesk libraries. What that gives to you is a little bit more support for 3D geometry when you're reading and writing, and it's also now supported on Windows 64-bit with FME 2012, where it wasn't previously, so you've got much more capability there. The main thing though that this writer gives you when you write data using this process in FME, a recipient of the drawing file you create, when they open it up, they won't get this foreign DWG pop-up anymore. So AutoCAD likes to check that the drawing file, the DXF that it's opening, is from an official source. And if you create drawing files using the DWG DXF, the standard reader and writer, then this pop-up will appear, and sometimes recipients of the data may not proceed if they aren't sure what has created that data. There's also a Map 3D object data writer as well, so that's very important for working with AutoCAD Map 3D, and that is pretty useful. And there's support for Civil 3D as well, and this is really focused on BIM, building information models. So if you want to build building information models using Civil 3D, you can work with that data in FME as well with that reader and writer. So translating data, the next step after viewing some content is working with the data, and FME supports all sorts of different data types. I've mentioned over 275 data formats in the categories of raster, vector, 3D, LiDAR, XML. You've got support for all sorts of different capabilities within those data types. Some of you might not be aware, but the main reason that, or one of the very main reasons why FME came about back in '93 was to start resolving some of the main issues of moving data between GIS systems and AutoCAD systems. And it's still the #1 use case for moving data from CAD to GIS or GIS to CAD. So let's take a look at a little bit of transformation here. We're going to go from drawing data to GIS. The reason why it's such a problem is that often when you work with a GIS tool, you're much more interested in a regional overview of your area, of your data. But with AutoCAD, it's more likely that you're interested in a very small area and you're interested in just a small tile of data. So we're going to build a workflow here to show you how you can work with your FME data. So if we launch FME Workbench and generate a new workspace, and we're going to read in here some data, and it's going to be input as a DWG. So we'll specify the DWG reader writer, navigate our way to my data source. We have some distribution data, the same data set that we were looking at a few moments ago, and we're going to write it, for the sake of this exercise, to a GIS format, mapinfo tab as the output format, and we'll specify an output folder, and just make sure that we're reading this correctly, and we'll run that through. And we're opening up one drawing file, but inside that drawing file you can see there are 3 layers. So those 3 layers are highlighted here from source to destination. Now FME works with AutoCAD, and it's a file-based data set, which means that inside that one DWG there are many layers. When you write to a folder-based format like mapinfo tab, the result is that 3 layers inside one file in a DWG will end up with 3 tab files, 1 per layer that was in the drawing file. So we can put a little bookmark around our data to highlight what this is. So this is the DWG input, and the bookmark allows us to move all these features together. We select and bookmark the output. We're writing out to mapinfo. Okay, so that's the first part of the workspace, and if we just open up our output directory, you can see that there's no content in there at the moment. So we'll pop that on one side, and if we run this and process the data through, we should see that the DWG and its layers get translated nicely to mapinfo tab files, 1 per layer. Now we may want to do a little bit of transformation on our workflow, and that's relatively easy. We can just use some transformers. So we'll just nudge some of these feature types down a little bit, and into this location we're going to use the quick add capability to go and add in here a transformer called the length calculator. Dive into the properties of the length calculator, and we're going to create an attribute called pipe length. Copy the name of that attribute, go to the destination schema and add in the new attribute, and we're going to set that to a floating decimal, and we're also going to adjust the diameter value here to a floating type. Now you can see that the result of putting the length calculator in place is that we have a new attribute called pipe length, and that will write directly into the output data. We may then want to carry out a little bit of concatenation, because what you'll see in a few moments is, if I just write this out, so we'll before we do the concatenation, actually we'll just dive into here. We've got a capability or an ability to use a fan out option in FME. Fan out means that when a new attribute is received with a different value, it will create a brand new file. So we could fan out, for example, on the pipe's diameter. And if we dive back to the output directory and just delete the contents for a moment and run this again, you'll see that the water distribution pipes themselves are being fanned out into separate tab files based on the diameter of the pipe. Whereas down the bottom here we still have our water distribution nodes and meters. Now that's okay, but it's not ideal because the naming convention isn't great. So we're just going to select and delete those again, and we'll pop in here a transformer that I just alluded to a moment ago. We're going to get a string concatenator. So there's the string concatenator, and what we're going to do is specify a concatenation value here. So we're going to say that the first value is a constant, and this is diameter underscore, and the next value is an attribute value, and that's going to be set as the diameter itself. And we're going to write that into the diameter attribute, so we're just going to overwrite it. And that's the value that we're fanning out on the destination. So if we make sure there's no content in that directory and run it again, you can see that what is about to happen is that now we have a prefix on our names, so that we have only the 2.25 diameter pipes included in this tab file. So a quick way of transforming our data and writing that out from the drawing file. So we're going from CAD to GIS here. If we wanted to then take our data and perhaps move this feature type, this data, out to a different format, it's relatively easy to do. We can just map this, drop in a bookmark to indicate where we're going to write it to. We're going to write this out to KML as an output format, and to do this we need to add a new writer into our workflow. So we'll type in KML, specify the output location, and we'll call this pipes.kmz. So we want to compress the file into a KMZ file, and we're not going to add a new feature type because we're just going to move this one over to the KML dataset. And you can see that now my output map info feature type dataset here has got two feature types, and the KML data has got one, which has got the pipe work in it. So again, if we dive back to our output directory, select the content and delete it for the moment, and we're just going to go and run this workflow, what we should get now is two tab files, and we'll get a KML file, and the KML file will have a number of layers in it for the pipe data, and each layer is based on the unit of measure. So we'll just zoom in there to this part of the world, and you can see that we have some pipe details included here, and that's a diameter 4 pipe. So we can turn off all the layers and just turn on the features that are diameter 4. So just a brief exercise there to show you how you can build a workspace very quickly to work with your AutoCAD data and move it into a GIS environment or put it into GIS formats. These blue connections here are transformers, and there's over 400 dedicated transformers that you can go and take a look at in your transformer gallery to see what transformers are available. There are also some categories. Worth taking a look in the categories for different classes of transformers and what they carry out, what effort they can carry out on your data. You'll see that there are ones in blue here that are standard transformers, and there's also some custom transformers that are available through the FME store now. So you can go and take a look at the FME store transformers and what are available, and you'll see that, for example, One Spatial have created something called a UK postcode validator and made that available through the FME store. So you're welcome to download any of those extra tools to use with FME. So let's just close down our workflow and dive back to the presentation, because we're now going to focus on styling your data. So have a look at some approaches that you can have to styling your AutoCAD data. There's quite a few options. Each geometry in AutoCAD has a unique set of styles. You can work with AutoCAD blocks if you're familiar with blocks. You can work with polylines, areas, and also text, and the styling of the text can be controlled. There's a number of ways that you can style your data, from simple methods through to more complex capabilities. Very simply, you can work with a transformer called the color setter. The color setter has been around for a little while in its present guise, but previously it was known as the pen color setter and the area fill color setter. Alias names have been introduced into FME to allow you to search very quickly, and if you're a long-standing FME user, there are now alias names that include British spellings, so that you don't have to worry about searching for the transformers and spelling words in the typically American way. So we'll take a look at a number of capabilities on the styling front, and the DWG Styler is one transformer that is worth looking at. If you're interested in working with CAD data in one of the rival applications, one of the rival CAD products like MicroStation, MicroStation is you can work with a transformer called the DGN Styler. So you have something called a MicroStation drawing file, and those can also be styled with the DGN Styler. So let's take a look at styling capabilities. If you want to work with a number of different formats and format styling, MapInfo, KML, PDF, DWG, DGN, they all have their own specific styling transformers. So we're just going to open up a workspace that I've got previously prepared here to show you how you can deal with styling capabilities. This is one I prepared a little earlier in typical fashion, but you can see here that the same data set here uses the color setter. If we go and search for color, you'll see what I mean about the alias names. So we can see if we search for color, we have an option for a color setter. We can also search for color setter and spell it in a different way. We've got different transformers here, so we can choose the color setter and it drops it onto the canvas. If you've been used to searching for things like the pen color setter, then you can search for the pen color setter and you'll see that you still get the color setter. Now this may seem confusing, but really this is specific to long-standing FME users, so that if a transformer's name has to be revised for any reason, you can now still find it nice and simply. If we dive into here, you can see that you have the ability to set the pen, the border color of your features, and also the fill color as well. So here we've just set the features that are nodes, we've set them pink, we've set the text to be blue, and we've set the pipelines themselves to be yellow. So if we just disable this link for a moment, and we're going to redirect our data out to the universal viewer, so redirect to visualizer, write the data out, and now if we zoom in, you can see that we've styled our features. So it's quite possible that you could have a workspace that reads data from AutoCAD and writes it out to AutoCAD, and you can see that's exactly what I've done here. I've read in a DWG and I've written out a brand new DWG using the real DWG writer, and I've created a new drawing file. So if we just enable this pipeline here and allow the data to come down this pipeline into the DWG styler, you can see that what I've done in this workflow is use the DWG styler to specify the text style. So I've created some multi-text, I've specified the font and the justification included in here. But if you were working with areas or lines or indeed blocks in AutoCAD, you could use these settings to specify different types of capability on those features. So it's a very useful capability. So if I turn off the redirect option this time and run this, redirect to visualizer means that the output data is not written. You don't actually produce any content. Now I'm actually going to write the drawing file out onto disk, and you'll see that if I go to my output directory, we have a distribution new file. And I'm going to open that up in AutoCAD TrueView, and I'm just going to drag that into the window here. And you can see that what I've got is the ability to take a look at my data, and I have some lines, nodes and water meters, and this is the revised text layer. So we can go in and take a look, and here we can see that we have one set of text. This is the original set of text, and this is the new font and the new offset that we've applied in that data set. So we could go in and turn off the original text and just live with the data that we've got. So that's the data saved directly into the drawing file and opened up in a CAD product. We can step it up a little bit and use some advanced styling capabilities. And one thing that you can do with FME is use a transformer called the Schema Mapper. The Schema Mapper allows us to store a lot of styling information, as well as all sorts of other things actually, in an external repository. In the case example that I'm going to show you, I've used a spreadsheet, but there are a number of formats that you can store information in. And ultimately what you can use that to do is to work with the very specific attributes or format specific attributes that FME exposes to you. Actually, AutoCAD formats are one of the most configurable formats that FME supports, with over 400 of these attributes, these format specific attributes, available for you to populate with values. And that means that you can really control how an AutoCAD drawing file or a DXF looks and feels when you open it up in CAD. So you can set the color, the block name, define line patterns, and a number of other capabilities directly with FME. And you can use the manual standard workflow processes in FME to do that, or you can use transformers like the Schema Mapper. This makes it very useful when you start to consider working with CAD standards. If you want to go and take a look at BS 1192, this is just such one of those CAD standards. The British standard really determines how you should work with, manage, produce, distribute, and define the quality of your CAD systems. And you can use FME to enforce some of those CAD standards, which can often be a little bit challenging. So let's take a look at how we can approach that method. We'll close down this workspace that we have open, and we'll open another one. So the first thing we're going to do is highlight that we're reading CAD data and writing out CAD data. So it's not always necessary to translate with FME. We are transforming our data within this workflow. Let's go and take a look at some of the source data, and we're going to open that with the universal viewer. So this is a little bit of Ordnance Survey data that's been processed and held within a DWG. We've got a number of layer names included in here, and you can see if we zoom in, you can see we've got some buildings and some line work available there in that AutoCAD file. So if we just zoom extents, some styling has been applied to this drawing file, but we may want to adjust that. And what I've used here is a spreadsheet to store some of those styling capabilities. Here you can see that I've got a layer name defined, and I'm storing the layer name that I record my data in included here. And I may want to move the data to different layers, so I'm going to write the data out, and I'd like, for example, these layers here all to go onto a brand new layer in a new AutoCAD file called CENT, and anything here goes into the line layer. I'm also going to define some new colors, so I'm going to set the value of FME color. In this case, this is a RGB value, so this is going to be layers are going to be defined as blue, these will be defined as red, and these layers down here will be defined as green. So I'm using the spreadsheet to determine this capability. How that actually works in FME is that I'm reading my drawing files into my workflow, and if I show you by double clicking and diving to the advanced browser, you can see that I'm reading star.dwg, all drawing files in that directory, and I could choose to go and ripple down into subdirectories as well if necessary. So all the drawing files come through the workflow. The attribute exposer goes and expose is an attribute called FME base name, and that contains the file name of the drawing file. So we're going to then rename that to something more sensible. We're going to call it file name. We can then use a transformer called the feature type extractor. The feature type extractor grabs the layer that features came from, and we're putting that into a layer name called layer name before. So we're going to have a before and after process here. The schema mapper transformer is the key. This transformer then joins to the Excel spreadsheet, so you can see that there are a number of formats that are available to us. Not all of the formats that FME supports are available for the schema mapper, but typically some of the main non-spatial formats are available where you can store information about your mappings, and you can see that here I'm using Excel as my input format, and that maps to the spreadsheet, and we're reading in the mappings tab of this spreadsheet, which is here. So if we go next, it connects to the spreadsheet. What we can do with the schema mapper is we can map features, so we can map features from one layer to another and physically move them onto a new layer, and we can map attributes amongst other things. So here you can see that if we go in and edit this connection, source feature type field name is layer name, destination feature type is a new layer name. If we show the table, this is the spreadsheet, and we're saying that we want to move from this layer and move the feature on to our new layer called area. Here we're going to go in and edit the color, and if we have the data value, if the data sits on the layer area mosaic, then we're going to map in the value that is in new color and change the color of all the features on that layer. We're then going to go to the feature type extractor again, and just as a bit of proof, we're going to extract the new layer name and put that into a new attribute so that you can see that. The significant thing here is that we are operating both a fan out on the attribute to make sure that all our new layers get written using our layer name after, and then we also on the writer, you can see using the option here that we have a fan out defined on the writer as well. So we're fanning out the data set, and we've said yes to our output directory, and we're prefixing all our drawing files with a revised value, and then we're putting using the file name that we had in the data before and suffixing with a .dwg. So the fan out capabilities are very useful in FME to fan out and create multiple drawing files in this case and multiple layers in our data. So here, if we just prompt and run and make sure that we're reading our data from the right place and writing to the best location, and we can run this through, and we're reading our drawing file data here, and we're writing out to our new location, and that's just completing, and the translation was successful behind the scenes. So now we can go and open up our data and take a look at the difference. So the file that we opened up before was NJ5339. If we go and get the revised version, NJ5339, drag that into the universal viewer and drop that in and go and take a look, you can see that now we have 6 differently named layers and a series of different styles. And you can see we can zoom in and quickly see the change when I toggle between the two datasets. So it's a very useful way in FME of managing the mapping of your features, and the spreadsheet method or the schema mapper method is very useful for that. You can give this spreadsheet, once you've set the template up, to a colleague who necessarily doesn't know how to use FME, get them to map all the data as they would like it to appear, and then you can use this to consume this spreadsheet or an Oracle table or any other format into FME to manage your styling and your design of your output formats. So it's a little bit more advanced, but certainly when it comes to styling, it has a great deal of capability. Now we're going to take a look at tiling and filing your data for use in AutoCAD. Many users of AutoCAD are familiar with the fact that typically you work with data in tiles. AutoCAD itself, and especially AutoCAD Lite, likes to work with smaller file sizes than you might be used to in a GIS. And the best way of dealing with that is tiling your data up. So if you have data in a GIS system like ArcGIS, and you have shape files or file geodatabases, you can take that data that covers a significant area and you can tile it up into pieces so that an AutoCAD user can more appropriately use that. A couple of transformers to take a look at when you're tiling data, particularly for AutoCAD use, are the tiler transformer and also the raster tiler. They allow you to specify the physical size of the tiles that you want to write out, so worth taking a look at. The other very useful transformer, and one that we're going to see in this next exercise, is the clipper transformer. The clipper is extremely powerful because you can use it to clip out vector, raster, 3D data. You can use volume to clip these days using the third dimension, and you can work with LiDAR data and clip out LiDAR as well if you wish. With this example we'll do some vector clipping, so we'll go and take a look at that now. If we pop open one of our previously created workspaces, you can see here that what we've got is the clipper transformer defined, and I'm just going to maximize the screen a little bit so that you can see this in a bit more detail. And if I just right click and go and inspect this data set, it forces open the universal viewer, and we can take a look. And here there is one layer inside this city grid file, and this is an Esri exchange format. You can see that there are some polygons tucked away in here, and each one of these polygons has a value, and the value here is tile name. In this case L24 is the name that we're going to find useful. And if we just go and right click on the roads data and open the containing folder and grab the shape file that we're interested in, move that to the universal viewer and read that in, zoom extents, you can see that we have some road data that covers our tiles, and we can individually click on one of the tiles and also some of the individual roads. And what we want to do is clip the roads exactly where they fall within each tile area, and essentially create some brand new files, one per tile. So this mechanism is pretty easy to do within FME. The clipper, really the benefit here is that we're carrying out clipping because we already have a pre-configured grid to use as the cookie cutter for our data, whereas the tiler and the raster tiler that I mentioned earlier on are ways that you can use FME to create a grid on the fly, if you like. So in this case we're reading in our polygons into the clipper. The clipper is set so that the clippers are arriving first, and we're choosing to merge the attributes from the clipping boundaries onto our vector features, and they will get a prefix of clipper underscore. The reason we want to do that is because what we want to do is capture the tile name and glue that onto the roads themselves so that we understand which road falls inside which boundary. We're then going to use a length calculator to calculate the physical length of each road, and an aggregator will aggregate up all the roads based on the tile that they fall within, and we're also going to sum that length so we get an understanding of how long, how far each road stretches within each of those tiles. And then just for visualization purposes we're going to use a random color setter, and with this offset mode it means that no two colors will sit next to each other when we write the data out. And at the moment we're just choosing to send this data straight to the viewer so that you can see the results of what we've just achieved. So it's very quick, reads the process, and you can see here that what we have is, if we just remove the tile, you can see that if I zoom in on a particular area here, I can click on a set of roads, and that's an aggregated set. And if I turn the tiles back on, you can see that that collection runs right over an edge. So you can see that if I select here, that road has been clipped at that location, as has this one clipped at both ends. So we're actually physically cutting the data in based on the tiles. So if we just go back to our view here, there we go, and we're just going to re-enable the output, disable the viewer, and we'll also disable this transformer for the time being. You can see that I'm basically writing the data out into my roads layer, but I'm choosing to fan out again on the output. So you can see here that I have set up a fan out on the data set based on the clipper tile name this time, so that I have a DWG for each tile area. And if we write this out, and while that's happening, go and take a look in the output directory, you can see that slowly we end up with a DWG appear, which will only contain roads per tile. And there's our output. Now if I right click and choose to open with, and I'll pop this open with the universal viewer. And here you can see just one tile area. And you can see that this tile is just for the tile of L27 and includes a layer called roads. So a nice little exercise, hopefully, to show you how you can use FME to tile your data and file your data into different file types. Okay, and just to finish up, we're drawing to the close. I wanted to show you a last capability, which is using FME as an application extender. So within AutoCAD there is a capability called FDO, or Feature Data Objects, and this is an API that allows you to access different data formats natively within the AutoCAD map data, the AutoCAD map product. So using different FDO connectors, you can connect to vector file formats, a handful of raster formats, a few relational database types, and also some of the OGC web services, so web map and web feature services. And you can do this without any other software other than AutoCAD. You do, however, have a limited set of data formats that are accessible via FDO. But it means that the capability of AutoCAD is more than just working with DWGs and DXFs. This is what the FDO connection window looks like. You can see here the ability to connect to, for example, shapefiles, Oracle database, an ODBC connection, MySQL, and also those web feature and web map services. And essentially what FME allows you to do is opening up the integration console, which is accessible through your start bar and there in your desktop install directory. Under utilities you can pop open the integration console, and it will show you exactly what products you have on your machine that could be extended by your FME license. I here have MapInfo Professional and also ArcGIS. They are essentially, I'm injecting my FME license into those products to increase their format reach. And essentially what you'd see in the FDO window in AutoCAD Map is an Add FME Connection option, which then allows you to connect to any data format that FME supports. So you can access different data sets, like, for example, GML or MapInfo Tab, which are obvious connection formats that are missing in the standard out-of-the-box AutoCAD Map capability. So really you can get a good return on investment from your FME license purchase by using it in conjunction with other products that you have installed on your machine. The one thing that's important though is that since FME 2011, AutoCAD Map 3D is only compatible with 64-bit FDO providers. So you'll need the 64-bit version of FME to be able to extend AutoCAD Map 3D. If you want to download the 64-bit version of FME directly from safe.com/downloads, alternatively you can email us at fme@onespatial.com and we'll tell you a little bit more about how the 64-bit version of FME can benefit you. For now though, I'd like to thank you all very much for listening to this session. Some post-training resources are available on our website at onespatial.com/FME, and as I say, you can email us at fme@onespatial.com to get access to an evaluation license. You can comment on this training or find out about our classroom training sessions, as well as the UK postcode validator custom transformer that I mentioned earlier on in this session. Alternatively, or as well, you can go to safe.com and both FMEpedia and some of the other resources that are available from the FMEpedia webpage. There's thousands of articles and how-tos on that site. I very much recommend you taking a look at that location. In addition to these resources, one thing to say is that this session has been recorded and it will be available on OneSpatial's website in our video box here, and also available over on our YouTube channel at youtube.com/OneSpatialGroup. So thank you very much for your time, and I hope this session has been useful to you, and tune in again in the future for the additional webinars that we'll be doing in this series, which you can register for on our website at onespatial.com/FME. If you want to get in touch directly with myself, here's my contact details, and as I say, thank you very much indeed.